In this video, you will learn how to find the probability of an event. So to begin, we want to understand what do we mean by probability. Well, probability is a broad category, and it's the likelihood that an event will occur. Now, there's different types of probability, and what we're concerned with in this lesson is what we call theoretical probability, which is what is expected to happen based on mathematics. And theoretical probability we can calculate by dividing the number of favorable outcomes by the number of possible outcomes. And when we say favorable, what that means is things we want to happen. All right, we'll look at some examples of that here in a moment. So mathematically, we can say probability of an event is found by taking the number of favorable outcomes dividing by the number of possible outcomes. Notice the notation right here. We use the letter P for probability, and then parentheses, and whatever's in the parentheses is what we're wanting to find the probability of. So if you're flipping a coin, for example, and you want to find the probability of heads, you can write it like this. Probability of heads would equal something. Now let's take a look at a few examples of finding the probability of different events. So example 1, we're asked, when flipping a coin, what is the probability of landing on heads? So our favorable outcome is what we want to happen. And what we want to happen is for the coin to land on heads. So our favorable outcome is heads, and that's only one outcome, one thing we want to happen. Now in flipping a coin, the total possible outcomes would be 2. It could be heads or it could be tails. So what we do is we can find the probability of heads by taking the favorable, the 1, dividing by the possible, which is 2. So we take 1, divide by 2. And notice the notation. We have P and then parentheses, and what we want to happen inside of the parentheses. So probability of heads would equal 1 over 2. You could write it like this, or it's best to write it as a percentage. Okay, so if you convert to a percent, you have to know how to do that. And this one, 1 over 2, you should have memorized to be 0.5. And to convert to a percent, you move your decimal point over 2 places. So you have to put a 0 here, and that gives you 50%. So we can say the probability of landing on a heads when you flip a coin is 50%. Here is another example. When rolling a die, what is the probability of landing on the number 4? Now it's worth pointing out that the word die is singular for the word dice. All right, so some people don't realize that, but a die is singular for dice, and when you roll a die or dice, it has 6 sides, right? So each side has numbers 1 through 6. So 1 is on one side, 2 is on another side. And so there are 6 total possible outcomes. But what we want to happen is for the dice to land on a 4. So to land on a 4, that's only one thing we want to happen. So our favorable outcomes would be just one thing. We want it to land on a 4. And we've said the possible outcomes would be 6 because it could land on 1, 2, 3, 4, 5, or a 6. So the probability of 4, so P parentheses 4, would equal your favorable 1 divided by your total possible outcomes, which is 6. So we take 1 and divide by 6. You could write it as a fraction, but it's best if you know how to convert to a percent. And so this one, 1 over 6, if you don't have it memorized, what you do is you divide 1 by 6. Put a decimal point here and a 0. And then you see how many times does 6 go into 10. Well, it goes in 1 time. 1 times 6 is 6. Subtract and we get 4. Then put a 0 here and bring down and repeat. 6 goes into 46 times. 6 times 6 is 36. Subtract and we get 4 again, which is what we had right here. So when you put a 0 and bring down again, it's going to repeat itself, where the 6 will keep going on forever. So what we have is 0.16 repeating, which if you convert to a percent, your decimal point moves over 2 places. That gives you 16.66%, which you can round to 16.7%. So for all of these, if you don't have them memorized, you could divide like this to find the percent. But it's best to have some of these common fractions memorized, as a decimal, and then from there just move the decimal point 2 places to write as a percent. Example 3, we are asked when rolling a die, what is the probability of landing on an even number? So on a die or dice, there are 6 sides, numbers 1 through 6. So with the numbers 1 through 6, the even numbers would be 2, 4, or 6. So that is 3 favorable outcomes, 3 things we want to happen. Okay, one of those numbers. And with a die, there are 6 possible outcomes because there are 6 sides on the die. So to find the probability of rolling an even, we would take the favorable of 3, divide by the possible of 6. So we have 3 divided by 6, which is equal to 1/2, which is 0.5 or 50%. So the probability of landing on an even number would be 50%. Now with probability, there is really any type of question you could see. Could be, picking a name out of a hat. Could be, the spinner. Could be, probability of it raining or whatever. So there's all sorts of possible scenarios you might come across. But for each of those, it's going to be the same type of setup, where you take your favorable outcomes, so like what you want to happen, and divide by the total number of things that could happen. Now, one other thing is we have this term called complementary events. So complementary events are events that are opposites. And with this, the sum must equal 1 or 100%. Now, what does this look like? Well, let's say, for example, that the weatherman says that there's a 30% chance of it raining today. So the complement would be the opposite. So what are the chances of it not raining today? So if there's 30% chance of raining, you'd have to subtract this from 100% to get the complement, which is 70%. So we can say that there's a 70% chance of it not raining today. Because when you add these together, 30 plus 70, that gives you a 100% chance. So one of those two things will happen, right? It's going to rain or not rain. So if you add those together, those complements, it must always equal 100% or 1, because that's the only two things that could happen. Now here's another example with a fraction. Let's say we have a name or a hat full of names, and we have a 3 out of 5 chance of drawing a girl's name from a hat. So the complement would be what is the probability of not drawing a girl's name, or drawing a boy's name, in other words. All right, well, if we know that this must add with the complement to equal 1, the question is, what do we add to get to 1? Well, 1 is the same thing as 5 over 5, right? So 3 over 5 plus what would give you 5 over 5? Well, 3 plus 2 would give you 5. So if we do 3 over 5 plus 2 over 5, that gives you a total of 5 over 5, which equals 1. So the complement would be that there's a 2 out of 5 chance of not drawing a girl's name from a hat, which again, that would be the same thing as of a chance of drawing a boy's name. All right, so that's the complement in this case. So the complement must always equal 1 when you add them, or 100%. So we've talked about complementary events, and here is another example with a different context. So in this example, we have marbles inside of a bag. And we have 5 red marbles, 3 green, and 2 blue marbles in a bag, and we're picking one at random. The question is, what is the probability of randomly picking a blue marble, and then using that to find the complement? So what is the probability of not picking a blue marble? So when picking a blue marble, we have 2 favorable outcomes. We have 2 blue marbles, 2 to choose from to get what we want. So we have 2 favorable outcomes. Now the total possibilities, the total outcomes, is we have 5 plus 3 plus 2 marbles, which gives you 10 total. So there are 10 total possibilities. So to find the probability of picking a blue marble, we take the favorable, which is the 2, divide by the total outcomes, which is 10, and that gives you 2 over 10. And as a percent, we can convert to a decimal first if you need. That would be 0.2, which 0.2 would be 20%. So to find the probability of it not being blue, which would be the complement, we would take 100% minus 20% to get 80%. So if there's a 20% chance of picking a blue, there's an 80% chance of not picking blue. So in this lesson, we've learned how to find the probability of different types of events and how to find the complement as well. And that concludes our lesson for today. We will see you next time.